Amine reactions are really limited. Okay, we only have 2 or 3 reactions to do for amines. The rest we pull from other chapters also, but so here you're going to see all sorts of different reactions. The first one is a true amine reaction, which is treating an amine with excess of methyl iodide and silver oxide. So when you treat an amine with excess of methyl iodide, you end up getting Hoffman elimination. Okay, so the first reaction here is actually Hoffman elimination. And with Hoffman elimination, remember you end up getting Hoffman product. Hoffman product is an alkene, and that alkene is less stable or less substituted. Okay, so in this case, you have this carbon right here where the amine group is. So which means you're going to form the double bond either on this carbon or this carbon. Okay, so if you form a double bond between let's just call this alpha for saying sake. So between alpha and the 2, you'll form a Zaitsev product. With alpha and 1, you're going to form the Hoffman product. Since this is Hoffman elimination, we are obviously going to form the Hoffman product. So this is the only product you will get. You will not get the Zaitsev at all, and that is the nature of this reaction. Okay, so the second one is also Hoffman elimination. So in this case, you're going to figure out what the starting material is. So looking at the product that we have, you want to make sure that your starting material has the amine in the right place. Okay, so this is going to be that skeleton that you have. Now you want to make sure that the amine is going to be in the correct position to give you a Hoffman product. So remember, a Zaitsev product would be something like this. Okay, so if you put the NH2 over here, then you can form an alkene right here, which is the Hoffman alkene. All right, now you don't want to have the amine here, because if you do, then you can form an alkene here or here. All right, and you don't want to have 2 products in any of your synthesis, so avoid it as much as possible. Okay, so that was the second reaction. Let's look at the last one here now. So the last one is a little bit more involved synthesis because you're adding a whole group, okay, to the benzene ring. So what is added to the benzene ring? Let's look at this. So this is actually an amide. So how do you make an amide? You make an amide from an acid and amine. Okay, so which means that on the benzene ring I have to add either an acid or an amine group. Okay, now looking at the connection point right here, so the nitrogen is connected to the benzene ring. It means my amine group is going to be from the benzene, which means that I need to make aniline. That's going to be my amine. Okay, and so how do you make aniline from benzene? Well, you do the nitration, HNO3, H2SO4, and then you go ahead and reduce that. You can reduce using LaH, lithium aluminum hydroxide, or you can also use tin and HCl in order to reduce the nitro group. This should give you your aniline. Now let's look at the second part. In the second part, you're actually adding the amide part or the carbonyl part, so which means we need an acid. Now generally we don't use an acid when we want to form an amide. You want to use something that is more reactive, and something that is more reactive are acyl chloride. Okay, so we'll use acyl chloride here. So you can see that this one is not a one-step synthesis. This is 2 or 3 step. It's not exactly a reaction that you covered in the amines chapter, because yeah, is it really an amine reaction? Well, yeah, sort of, okay, because it's a reaction between an amine and an acid. So you've done this before, now you just get a good review.